Hello, bonjour, it's Laura here. In this video, we're going to practice classifying chemical reactions based on their chemical equation. So I just want to go through what you need to look for. So in this chart, we've got kind of a cheat sheet of what to look for when you're looking at a chemical reaction, and then we can refer back to this. You could even print this off and have it handy so that you can refer back to it all the time when you're doing your homework. So the first one is a combination reaction, and this should be familiar to you. And what you're looking for here is two or more reactants that are forming one product. So these are the numbers that are important. The next one is a decomposition reaction, and this is basically the opposite of a combination. So you're looking for one reactant, and then it's splitting into two or more simpler substances. The next one would be a single replacement. So this is one where you've got one little uncombined element, and it's kicking out the element in a compound. So they're kind of rearranging. So that's a single replacement. Double replacement is very similar. So you've got two compounds, and then elements in those compounds are switching places so that you end up with two different compounds in your products. And then with a combustion reaction, you've always got the reactants are always going to be some type of hydrocarbon compound like propane or some alkane plus oxygen. And then you're always going to produce carbon dioxide, water, and then energy. And remember, energy doesn't always show up in the chemical equation. Okay, so keep these things in mind, and we'll practice classifying some reactions. So the first one here, we've got magnesium, we've got oxygen gas, and then we're forming magnesium oxide. Okay, so what you can look for here, first thing, how many reactants do we have? We've got two of them. How many products? We've got one. Do we have anything kicking out or replacing? No, we don't. We're not producing carbon dioxide and water, but we're going from 2 to 1. So that means that this is going to be a combination reaction. Okay? Let's look at the next one here. So here we've got one reactant, and then it's splitting into two products. So we've got mercury oxide here, and then we've got two products, mercury and oxygen. So do you remember what that's called? It's kind of the opposite of a combination. That's a decomposition reaction. Okay, let's look at some more. So in this one, we've got zinc. It's a solid, and then we've got hydrochloric acid here. And then, so we've got two reactants. And then in the products, we've got zinc chloride and hydrogen gas. So we've actually got two products here. So we're not combining and we're not decomposing. And so see if there's any switching of places going on here. And there is. The zinc is replacing that hydrogen. So do you remember what that would be called? That's going to be a single replacement reaction. Now let's look at this next one here. So here we've got two reactants, and we're ending up with one product. So there's not switching of places going on here. Do you remember what this one would be called? That's a combination, because we've got two combining into one. What about this one? So here we've got a compound breaking up into two. So we're starting with one here, breaking up into two. So that would be a decomposition reaction. Now let's look at this next one. We've got two reactants. We've got two products. Is there any switching of places or replacing going on here? So if you look, the hydrogen and the sodium are switching places. So the chloride is now with the sodium when it was with the hydrogen before, and then the sodium has left the oxide here, and then the hydrogen has taken its place. And notice this is HOH, the liquid. That's actually water, so it could also be written as H2O. Okay, so that would be a double replacement reaction. The next one here. So we've got 2 reactants, 2 products, so it's definitely not combination or decomposition. Have we got some switching of places here? Yes, we do. So we've got iron, and it's replacing the copper. Is this going to be a single or a double replacement? So the way you can tell is that you're starting with a single element here, and then you're ending with a single element. So what's happened is not a double, but a single replacement, because you've ended up with, you've started with a compound and a simple element, and you've ended with a compound and a single element. If it was a double replacement, you'd end up with, you'd have 2 compounds to start, and you'd end up with 2 compounds. So the difference is the presence of the element there. Okay, so let's look at the next one here. So we've got methane, we've got oxygen as our product, or our reactants, and then we're ending up with carbon dioxide, water, and energy. Okay, so that is going to be a combustion reaction. So remember, you can have any type of fuel to start. So an alkane, this is a methane here. And then you're going to also start with oxygen, and then you'll always end up with carbon dioxide and water, and then energy. Here's another one. Okay, very similar. Look at this. We've got a propane, or an alkane here. That's butane because it's got the 4 carbons. We're starting with oxygen, ending with carbon dioxide and water. So again, that's a combustion reaction. It's got all the characteristics of a combustion reaction. Combustion reactions are really quite easy to spot because of that oxygen, carbon dioxide, and water. You always have those. All right, let's look at the next one here. So here we've got 2 products, 2 reactants. So we know it's not going to be combination or decomposition. So we know it's going to be a replacement reaction, and we just have to figure out whether it's going to be a single or a double replacement reaction. So if you look, we've got a compound here and a compound here. So we're starting with 2 compounds, and then we end with 2 compounds. So the sodium and the silver, they've actually switched places, and they're in 2 new compounds. So if you've got 2 compounds to start and you end with 2 compounds, that's actually a double replacement. Okay, so double replacement there. All right, so well done, Miigwech. So make sure you practice and print off that cheat sheet if you need. Okay, thanks a lot. Till next time.